Hey everyone, and welcome to lesson 1.3, which is inverse trigonometry or inverse trig. Um, in class, I'll be starting this lesson with just kind of a video um, problem where we can use trig in the real world. And that might be a video that I still have you watch. I've kind of yet to decide on that. But if there are any kind of interesting points that you want to jot down, or maybe some of the diagram, I think it does kind of have you pause it at certain points to attempt some stuff. But it's a short video and it's just used for how we might use trig in the real world. So it's kind of interesting. For inverse trig, which is going to be our topic today, we should be able to find some pretty quick success with it. It's not all that much more difficult than trig to begin with. So here we're just going to kind of jump right in. And what we have essentially when we look at this triangle is a setup where, if I were just going through the motions of our last lesson, potentially labeling opposite, hypotenuse, and adjacent. The difference that I'm finding here is that I actually don't know the angle, okay? But let's kind of maybe pretend that I do, or just write the equation that relates all of these pieces. So here I have, I have adjacent and hypotenuse. So based off SOHCAHTOA, if I have adjacent and a hypotenuse, I'm concerned with cosine. So I am going to at least start off with saying cosine of y is 18 over 20. Okay, so that's the equation that I can write. The only adjustment that we need to make to this in order to find our y value or our angle is to recognize that basically I need to solve an equation and I need to undo cosine. Okay, y is being cosigned. So how do I undo that is kind of my question. And what I would highlight is that if I have something that I'm looking to solve, there's normally a solving tool or step that I take that is its inverse. Okay, so if I have x squared equals 4, the inverse of that is the square root operation, right? So that little sidebar should help us kind of realize that over on the left, all I need to know is what is the inverse operation of cosine? And it can be written in two different ways, but essentially what we're just going to do is this operation, which is inverse cosine. So it looks like cosine to the -1 power, but -1 is generally something that we'll use to denote an inverse. So I'm going to apply the inverse cosine to both sides. And when I take the inverse cosine of y, I'm just going to be left with y. And then on my right-hand side, I have this inverse cosine of 18 over 20. This can be found on your calculators by hitting the second button before hitting cosine. So again, this is going to change depending on if you're a phone or something along those lines, but I'm going to essentially just hit the second button on my calculator, then cosine, and then I'm just going to be typing in 18 over 20 at that point. Again, if you're on your phone, you might need to do 18 divided by 20 and then second cosine. Play around with it until we arrive at the answer. So I am at 25.84, and that is in degrees. So I've figured out that this angle is 25.84 degrees. So it's very important that we are checking this on our calculator to figure out, do I have the same setup that Mr. Lynch is doing? Am I typing in all the numbers correctly? All of that same kind of stuff. So if you're not getting 25.84, it might depend on what device that you're on, and you might need to check some additional resources in order to get there, but that is what we should get. So we have this inverse cosine, which is pretty straightforward. This like elongated step here, where we write inverse cosine and then cosine y, we probably won't do super often. You'll see how I just jump through it in the future. But there are, obviously if we have tangent of theta, then we also have tan -1. If we have sine, then we have inverse sine. And then if we have cosine, then we also have inverse cosine. These are generally, if you're on a device, they look exactly like this, but in textbooks or other tests, things like that, they may be written in this form as well. So this is arc tangent, arc sine, or arc cosine. Okay, these all mean the same thing. It's inverse, and they could be used. So I believe if you're in Desmos and you were to type in arc cosine of 18/20, it would be able to tell you that that is 25.84. So it understands arc cosine. All right, so let's do some additional example problems, and I'll see, I'll kind of let you know how we're going to shortcut that step that I had highlighted earlier, just because it ends up being a little bit more writing than it's worth. All right, so here it looks again, so this is going to be opposite. Hypotenuse is across from 90. This is adjacent. So the equation that I can at least write is to say that the cosine of my angle is 14.3 over 19. And then in order to solve this, or in order to undo the fact that I'm looking for my angle and I have cosine, I'm going to actually take the inverse cosine of both sides. So here you can just kind of see that I'm just writing x there versus showing you that the inverse and cosine cancel each other out. I'm just going to be writing this, and then I'm going to plug that directly into my calculator. So I have inverse cosine 14.3 divided by 19. Oops. And I'm ending up with x equals 41.18 degrees. Again, if we're doing like a reasonableness check, I would generally look at the angle in that diagram and see if it makes sense that that is about 41 degrees. Here it does. I don't have any issues with that. If I got something again like 89, then I might want to have pause, or if I got something like 5 degrees, I may also want to have pause, but 41.18 looks good. So you use two different trig functions to confirm the below. So if I have all three sides, I really have my choice of any trig function that I want. So some people look at this and think that it's harder, but it ends up being that I can just use any trig functions that I want. And I'm going to show that basically in two different ways. So since I haven't used sine or cosine, maybe I'll just use those. So I have opposite, hypotenuse, adjacent. So two equations that I can use, and again, I'm just doing this for almost like proof purposes to show you that it doesn't matter what, if I have all three sides, that it doesn't matter, or just that, trig works in general. So I can say that the sine of my angle, which is alpha, can equal 8/17, equals 8/17. And then that would mean if I take inverse sine of both sides, then I will be able to figure out what that angle is. And I'm also, again, since we just haven't done tangent, I'm just going to figure out what tangent of that angle is, which should be 8/15. That would imply that that angle needs to be inverse tangent of 8/15, and I'm going to plug both of these into the calculator in order to kind of prove that I get the same thing. So inverse tangent of 8/15, I get 28.07. Inverse sine of 8/17, and I get 28.07. Okay, so this should be more freeing. If I have more angles to work with, I can use sine, cosine, tangent, anything that I really want, and be able to arrive at that answer. There is a word problem here. We're probably getting the hang of it, and there's going to be kind of a focus on word problems in a little bit. So to avoid this movie going too long, I'll probably just hit the pause there. Yeah, so there's some practice worksheets. I'll try to put the answers up as well. And I believe I've also got kind of a puzzle that is a mix of inverse trig, regular trig, and it's going to take some creativity and or problem solving. So best of luck, everyone.